So I started the recording again. So everything what you see online and hear my speech will be also recorded for later viewing. So the chat and that kind of things don't show up on the recording. And okay, so where am I? Okay, there's the control window. So chapter 4 of the Cisco Material Connecting Things, which is all about networks, fog and cloud computing. You may remember people a big fuss around fog. What happened to fog? We will actually hear it later. So what kind of things we have here? Connecting things to the network. Okay, network support, the IoT, and then some words about the fog and cloud computing, which is basically how to process data online in IoT kind of applications. All right, this is something you went through already on the first year classes, I believe. At least Joe Hotchkiss has given this. I think CCNA 1 and 2 are given already to most of you. So you know the local area network and the wide area network. And yeah, so basically you could have a network like this, two local area networks, for example, two offices, which has a different kind of devices there, and then internet network, which basically you can access this internet network in both from the both offices. For example, you could have the company mainframe servers in Myllypuro, which runs the OMAS system and other systems, and then you have these local area networks, campus-wide local area networks around that company, or actually university. Um, network transfers data, period. Yes, there are different network protocols. Uh, so like Ethernet protocol or IP protocol, TCP IP 4.0, 6.0. You have heard of those. You need to have a protocol in order to communicate. Then about routing, how to actually route the signal so you have when you, for example, click on your browser, how your get command goes to your, for example, that Amazon.de, how it's routed in between. Okay, that's routing. How to connect the signal where it's supposed to be going. Okay, and yeah, I don't think that needs more explanation than that. Yes, we need network to access anything, any information. Okay, IoT protocols. Okay, that's a little bit more interesting stuff. IoT devices are small, meaning that they have very limited resources, power wide, computing wide, storage wide, and then also the time wise, they are usually quite they say slow devices compared to any computer. So, and they could be also outside of the building, for example. If you have a local area network only on the building and your device weather station, for example, is outside, how to connect that information to the some standard way anywhere. So there are a couple of these protocols, more or less standards, like the constraint application protocol and message queuing telemetry transport. That kind of protocols are used on the IoT devices. Okay, and then of course again securing the network. How to secure a device which doesn't have much of the intelligence inside of it. So you need to basically um, have something to make sure that, well, your weather data doesn't go to somebody else's, or actually, how about your personal small device what you are wearing on your wrist? How do you make sure that your personal device cannot be accessed by somebody else and reading, for example, your pass rate and that kind of stuff, which is that's really a private information. Yeah, then we have wireless technologies. Actually, this is, say, quite interesting picture there. So short range, medium range, long range. Those long range means, say, tens or hundreds of kilometers away, like satellite links. They are a few hundred kilometers away. Short distance goes to like Bluetooth low energy, which is max 10 meters or so. Then there are, of course, that NFC, which is practically you need to have this NFC device in contact with the surface of that another NFC device. So very short range, up to say at least tens of kilometers or hundreds of kilometers. Then the bandwidth. Um, if you make the diagonal from here to there, the price goes up like that. So of course, so higher the bandwidth, more expensive it is, and then of course the shorter range, less expensive. Satellite data, very expensive. Okay, so, and what is the limit here? Well, they still, after 5G, they have already started discussion about 6G. It's already on the way. 5G is now on the implementation part, so 6G is coming. Of course, it will be faster. Some especially interesting wireless technology for IoT since is Zigbee, which is low energy, low power, low data rate wireless protocol. Means this can be utilized in small battery operated devices or battery with some solar cell. The additional support, they work even in Finland, except in, well, except in Lapland wintertime. But anyways, it says that Zigbee version 1.2 has a number of serious and exploitable security vulnerabilities. Not that much anymore. This is already old information. So, for example, there was huge fuss about these Philips light bulbs that anyone could practically hack. Not anymore. It's basically it was just a security issue which engineers solved. Okay, so just a moment. I need to get my Windows sorted again. Another one, Bluetooth technology, old-fashioned Bluetooth, BLE technology, Bluetooth Low Energy. Actually, if you didn't know, also the bus stops in Helsinki area already almost, I think all of them bus stops already have the Bluetooth beacon in them, and also the most of the buses already have the Bluetooth. So practically, this basically this technology is used already on these finding out where the bus is at which moment. Okay, 4G, 5G, well, those are the common current technologies on cellular data. And what else I can say about that one? It works, 4G works up to 100 megabits per second on, say, well, yeah, that 1 gigabit per second. I doubt that a lot. That, well, technology maybe, but you know, you are usually not alone on any place where you have that super fast 4G. LoRa technology, LoRa wide area networks, actually is quite interesting, since practically it's one way to send small amounts of data. It only have 300 bytes per second at the lowest, but then the range can be in even on the forest kind of areas, it can be about 1 kilometer or so, and also between buildings you can have that kind of things, and it's very, very low power and available, for example, from Amazon. Devices already are available there. In Finland, the LoRa network is built by and managed by and operated by the Digita. Okay, that was about the networking. Quite general stuff. You probably have heard of those, and you probably have heard more of that than that. Okay, cloud computing. What is cloud computing? Actually, it's a quite nice model. You can basically have a small virtual, or, well, if you have lots of money, a big virtual machine. You can have your cloud PC, have a real cloud PC, and you can actually install programs to that PC, and you can use it as any PC, but it's basically you don't own the hardware. The hardware is on the servers and these data centers, and basically you can buy or rent a virtual machine with practically nothing, and resources, meaning the expanding. For example, if you try a small business which has only 10 customers and you're selling some services to that and then you suddenly have 1,000 or 100,000 customers. With cloud computing model, it expands. So it's a scalable structure. You don't need more computers. You just rent more space on that cloud service provider. Okay, and reduces cost of equipment. Well, equipment you don't have. It's the cloud service providers equipment. Energy, well, you don't pay the energy bills except you pay rent. You don't have the physical plant. You don't need a separate these computer rooms or infrastructure. The personal training needs actually you can put the personal training into place. It really matters, not on keeping the system running, but to using it. All right, more about cloud services. Uh, okay, IoT system connectivity has been actually now during the last 5 to 10 years, it has been actually more and more of these functional IoT systems, and those are usually these device manufacturer will use some of their say proprietary thing, but what is behind is usually Amazon. If this then that they build.io, Webex, Teams, or well, Microsoft Cloud Services. Azure actually has been expanding a lot, and I think that's currently it's the main line for cloud services. But of course, this is Cisco material. They don't actually mention any of these the potential threats to them, except well Amazon. Um, yeah, nice picture. I don't know what it actually means. It's a nice picture. Oh yeah, cloud, fog, compute. Yeah, fog. What is fog? That was the idea 10 years ago, or more than 10 years ago. There'll be a little bit of things done in clouds, and then fog means locally on site. The computers make kind of uh, this computing pool that is used to solve the locally or process the data locally. Okay, that was 10 years ago. I think this is 12 years old slide. And this is also about its distributed computing infrastructure. So do the as much as you can locally and then just basically then this reduces the data burden of networks. So you don't have to transfer everything, all the data to those the cloud services or data centers. And when you don't have that kind of need for data transfer, then you don't have that much of security issues there. You are basically uh, analyzing or keeping the critical data inside of your the local area network or your you know the airport size network or something like that, and then also the connection machine to machine would go say smoother in that world. And anyhow, there's this line: Cisco predicts that 40% of IoT created data will be processed in the fog by 2018, and this slide was done 2008. That was their 10 years forecast. What really happened? Update at this time, 2021. Cloud fog computing, maybe less than 1%. So what happens is that you can rent those cloud services so darn cheap, and you can actually do lots of automation already there on cloud. Basically, there are these automation that like business intelligence. What is that? Power BI by Microsoft is made for business intelligence. You just uh, throw that your data into a secured cloud location in EU that would go to the in Ireland, Microsoft data center in Ireland, most probably it's their company's property, intellectual property there. Then there's this Power BI that analyzes the data and does the thinking right there, the machine thinking there. Okay, and dirty cheap compared to making a local fog infrastructure and hiring hundreds of engineers just to build the system. So, well, fog maybe somewhere for the very critical data that cannot go anywhere from the premises. Maybe fog is used there in some specific these applications, but cloud computing is the current uh, way of doing things. Word about big data. 10 years ago, big data was a big thing. But now we just try to go with that one. So data growth, it's still the amount of data is still, was it goes to 1.5 times every 1 year. So in 2 years, it more than doubles. And basically, at the same time, we are in a situation that this data transmission speed is not really anymore supporting this amount of data. So there are glitches on the data transmission, as we have seen, because there are so much data that's evident that at some point there will be a break in communication networks. So yes, however, that's not a threat. It's actually opportunity for engineering students. It's called their job opportunity. So basically, it's good for you that engineers are still needed. If we didn't have any technical problems, where do you need any engineers? Okay, and it's all about data. I like personally that middle things are typically characterized in 3 dimensions: volume, velocity, and variety. Meaning volume, the amount of data being transferred, stored; velocity, the rate at which this data is generated; and variety, okay, what kind of data. So, but anyways, if you want to know about more about big data and big data analysis, then we have some different courses for that one. And there we have these tools like where you analyze really big data sets like Apache Hadoop or WebEx Teams, Cassandra, Kafka. Those are the open source projects dealing with big data. And then, of course, the Azure handles with big data quite well. All right. Security concerns. Okay. Data storage locally if you put that on SD card, how safe is that? Secure. If you have a personal device which has memory, who can access that memory? Um, so then, of course, the more concerns about data transmission. If the in a transmission, if you don't properly secure the data, then it can be intercepted, meaning that then someone can take it off the stream, captured, manipulated. Uh, the NSA actually runs a lot of these intercepting and capturing kind of things. Manipulation, I have a feeling that it happens in some countries. Okay, and there's modern encryption algorithm may require more processing power than what is available in the IoT device. Not anymore. These even small IoT devices has lots of processing power. The processing power is not the issue anymore. It's more about uh, the people, talented people who can do it. By the way, Finland actually has some of these companies which are uh, basically the making these embedded, especially embedded Linux software on this security side. There's one company I don't. It's Tuxera. Yes, Tuxera company in Helsinki. They actually their code is used in most of the embedded Android devices in the world. They make security for SSD, the storages. That kind of small niches. Okay, and yeah, attacks stuff, that kind of stuff. There, and then we have a summary again. Yes, data protection, data privacy are the issues. Then we have these wireless technologies, namely Zigbee, Bluetooth, well, especially Bluetooth low energy for the embedded systems, 4G, 5G, LoRa networks for IoT devices especially. And then wireless security is about secure protocol, protecting the management frames, identifying the frequency jamming, that kind of stuff. Cloud computing, yes, cloud computing have enabled these services like what is it? IaaS I don't remember it. SaaS. That's SaaS is actually software as a service. Other ones I don't remember anymore. Yeah, I'm an old guy. Fog computing. It was a big fuss, but didn't really take off. But anyways, if you ever heard of fog computing or get into a project that deals with the fog computing, it's just local kind of cloud computing. You can actually have fog computing uh, made in cloud computing platform. If you have that Hadoop, for example, install it locally on a local server, then you can actually use that one for the fog computing, meaning local computing. There, big data, yep. Big data and IoT, IoT devices are mostly the source for the big data. Or with some cloud computing, they also could be the kind of which controls what is analyzed from this data, big data. Yep. What else? That was the second of today's lectures. And any questions? If not, we will have again about 5-minute break. We continues with the exercise 11 and 12 tutorial at that will be 10 and 45. And I'll stop recording.